G'day students, I'm going to do a really hard lesson with you today. What can you see here? This is chocolate. This shape is called a rectangle. You can see that I've got a length of 2 and I've got a width of 1. Now, this looks like a non-isometric transformation. What's that? That's an enlargement or a reduction. Now let's work out the amount of reduction or enlargement we've done. Well, let's assume that this is the original. We've got a 2, 4, 6, and this is 2. Oh, so this is like 3 times. And 1, 2, 3. We've got a scale factor here, or a length scale factor of 3. We've had a dilation of 3, a scale factor of 3. But there's a little problem here. We want to look at the relationship between area or scale factor now and length scale factor. So if we've got a, what do we say? A dilation or a scale factor of 3, a length scale factor of 3. Let's have a look. What do we say? 1, 2, 3, 1, 5, 6, 18. 18 divided by 2 is 9. Okay, so we've got an area scale factor of 9. What I want to talk to you today about is that the area scale factor is the same as the square of the length scale factor. So remember we said the scale factor of the length scale factor was just 1, 2, 3, or 1, 2, 3. So 3 squared is 9. So the area scale factor is 9, but the length scale factor is 3. And I just read it a little bit. Good job. So, I had to do that. And you know, if there's parent-teacher interviews or something like that, and you want to get a good mark, no, just kidding. That's good chocolate. So let's have a look at our relationships today. We want you to be able to calculate area scale factors and find area using scale factors. So let's have a look at the main point. The area scale factor is equal to the square of the length scale factor. Now I've just written it like this down here. Area scale factor equals length scale factor squared. Now remember, area units like centimetre square, metre square, or square metre square centimetres, etc. are squared units. And they're length squared units. So it makes sense to get the area scale factor. We're going to find the square of the length scale factor. Now it also makes sense, and we'll look at this in a little while, that the volume scale factor should be the cube of the length scale factor because they're cubic units. But that's not today's worry, even though I'll talk to you about it because it's interesting. So area scale factor is equal to the square of the length scale factor. Now the formulas to use for the area scale factor are the same as for length scale factor, but you must always use the area measurements. So use a highlighter, area measurements, not the length measurements. So area scale factor equals image area over original area. So that's this bit here. Okay, and we can rearrange that formula just to say the original area equals the image area over the area scale factor. And the image area equals the original area times the area scale factor. Let's have a look at our first example today. I've got an original on the left and I've got an image on the right. Now if I have a look at this shape, they are squares. There's a length of 2 on the original and a length of 4 on the image. So let's work out our length scale factor. It's just the image divided by the original. So here's my image. I substitute 4 into there instead of writing the word image. And then over here, my original is 2. Now 4 divided by 2 is a scale factor of 2. So that's kind of straightforward. Now let's see what that means for area scale factor instead now. So if I have a look at my area scale factor, my image area, if I look at the square on the right hand side, it's 4 times 4, which is 16 squares. So what do we can see? We can count up to 16. So there's 16 square units in there. Now if I look at the original on the left, we've only got 4 squares. Okay, so 16 divided by 4. Now our area scale factor is what? 16 divided by 4. Let's see if I can find another pretty highlighter. Oh, looks like it's blue. So my area scale factor, no, that doesn't look like a highlighter. My area scale factor is, no, that's just painful then. Yeah, well, my area scale factor, where are we? 4 should equal the square of the length scale factor. What's my length scale factor is 2. So let's do that. So is 4 the same as saying 2 squared? Yeah, and of course it is. 2 times 2 is 4. So yeah, that holds to be true. Okay, now let's just have a quick look at volume, because that's also interesting, although it's not really required for today's lesson. So just remember, this volume scale factor is just the length scale factor to the power of 3. Now that makes sense, because your length times length times length is going to be 3-dimensional, or going to be to the power of 3. So that we call those sorts of measurements cubic units. And if we have a look at the original here on the left, I can see I have a rectangular prism. Well, we've got a, that way goes 2, that way goes 1, that way goes 3. So a length, depth and a height, for example. 2 by 1 times 3. If I look at the one on the right hand side, we've got 4 by 2 by 6. Anyway, let's work out our length scale factor. So remember, we need to find some corresponding sides to work out our length scale factor. So on my image, let's go yellow for image, I've said, oh well, let's use a 6, because that corresponds with this one over here. And that's just nice and easy to use. So let's say, well, 3 for the original. So 6 over 3, well, 6 over 3, I have a length scale factor of 2. Now let's work out my volume scale factor. So to work out my volume scale factor, I need to multiply for the prisms, rectangular prisms, what is it? Length times width times depth. So length times width times depth, or any of it. Multiply the 3 by those, and multiply each of them by themselves for a rectangular prism. So 4 times 2 is 8. 8 times 6 is 6 8 48. Okay, that's good. Now, let's work out the volume on the original shape. Well, it's 2 by 1, which is 2, and 2 times 3 is 6. So 48 divided by 6 is going to be 8. So I have my volume scale factor of 8. Now the relationship we're saying is that the volume scale factor equals the cube of the length scale factor. So is 2 cubed 8? Yes, it is. And so that fulfills this relationship here. So we just say, well, 8 does equal 2 to the power of 3, and we give it a little tick just to prove that. I'd like you to work on the mastery questions today, please, students.